let's look at what the commands false and true mean for the binomial distribution function. Here's a situation where I'm sampling 3 people from the PC population during the 2010-2011 school year, and I'm counting the number that passed mass 60. So my variable just counts the number that passed mass 60 out of my sample of 3. My random variable is x, so x can either be a 0, 0 people pass, 1 person passes, 2 people pass, 3 people pass. Now, below this, I want to write the probability of each of these values. Sometimes people mistake the following. They say, well, what's the probability that 1 person out of the 3 passes? And they write equal to 1 out of 3. The probability is 33%. That's not the case. If that would work, the probability of 0 out of 3 passing should be 0 divided by 3. This should be, all people should pass, basically. There would be no chance that no one passed. And that's not true, because we're saying there's a 68% chance of any one particular student pass, not a 100% chance. So that doesn't work. So this is where this command comes in. Suppose I want to know the probability of exactly 0, the probability that x equals 0. Then I would use this command, and the tag word is false, because I want to know just that value. Looking at my tree, I can see how I would get that value. I can get that value by typing 0.32 times 0.32 times 0.32. In other words, it could come out looking like this. The probability of 0 people passing would be 1 person doesn't pass, and another person doesn't pass, and the third person doesn't pass. Notice I'm using the independence clause because my sample size is relatively small compared to the thousands of students who have taken Math 60 during that school year. So there is that value. I can also get that value using binomdist, but because it's that particular value, I will type in false. So it's equal to binomdist. Enter that value. My sample size is 3. Probability of success is 0.68. And false. So I'm counting the number of students that pass. And there is my value. Same as before. Okay, what about 1 out of 3? I can enter binomdist. Sample size is 3. The probability of success is 0.68. And lastly, because I want just 1 out of 3, false. And if I wrote it right, it might work. Binomdist. There. That's a chance of 1 out of 3, not 33%. And I can get the rest by doing exactly the same thing. So now what does true mean? Suppose that I'm looking for the probability that x is less than or equal to 1. In other words, I want the probability that either x is equal to 0 or x is equal to 1. The answer is, well, add these two numbers up. This value plus this value. But if your sample size is 50 and I'm looking for 25 or less, that would take a while. So it just would be as easy to use this true command. The true is that value and everything below it all the way down to 0. So if I type binomdist and I enter 1, sample size of 3, probability of success is 0.68. Lastly, true, it will calculate 1, it will calculate 0, and then add the two together. Lastly, let me end with this. Suppose you want the probability that x is either 1 or x equals 2. So to accomplish this, I can do the following. I can again use the true command. It'll be binomdist 2. Trials is 3. Chance of success 0.68. I'll write in true, but that will give me 2, 1, 0, and a 1, 0. So I'll remove 0. 1 binom dist 0, 3, 0.68, false. Remove exactly 0. And I get this value, which is, in reality, what's 1 or 2 is the sum of these two. And it gives you the same number again. That's what false or true accomplishes.